Hey everyone, I'm Asher Russell and I'm here with Emily Wade.
Hi.
And we're the Engineering Chicks, and today we're going to talk about hospital simulation. So to introduce the problem, this procedure simulates a hospital ward with n number of beds. The patients arrive with a Poisson distribution and occupy the beds with a Weibull distribution. So a big part of this code was dealing with patients when there are no beds open yet. So if a patient arrives and there are no open beds, one of the following occurs. If the scheduled time for the next patient to leave is less than alpha, the current patient leaves now, so that's an early departure, and the arriving patient immediately takes their place. So if a patient shows up and there are no beds open, if a patient has already been there and their remaining time left in the system is less than alpha, that patient will just leave early and make room for the new patient. Otherwise, the patient can't be accepted and will be referred elsewhere. So on the next slide, we're going to introduce all the variables that are used here. Okay, so as you can see, we have a lot of variables going on here. Quite a few of these, if you're using a function in MATLAB, you put these in the beginning, and then the rest are just used throughout the code. So we have the duration of this simulation. As we talked about earlier, n is the number of beds in the hospital ward. These are the ranked scheduled departure times for the bed. And if this is infinity, that means the bed is currently unoccupied. Alpha is a threshold for the early departure. So we talked about on the last slide, we have two seeds. The clock is a present time. Obviously, clock previous is a time of the previous event. Delta is a time since the last event. And then just regular T naught is the departure times for the bed. And then A is the next arrival. NOCC is the number of occupied beds, so that's important. Q is either 1 or 0, according to whether or not there's a patient momentarily requiring admission. NA is a cumulative number of arrivals, and also number of admissions. And then this N out 1 is a number of normal departures, and the N out 2 is a number of early departures. And then N refer is cumulative number of referrals, and then this last one, cumulative J, is time for occupancy in beds. So here's the beginning of the code. You could choose to use a function in MATLAB, and when you run it, you could enter these variables, or you could just have them set in your code like this. And then, so we just reiterated what these were here, just to remind us. And then we have our seeds and setting up our betas here. Okay, so here we have our first for loop. And as a comment, we commented these out. So for this part, it's computing the number of beds occupied at the time 0 from the initial scheduled departure date for each bed. So as we talked about earlier, this is the number of occupied beds, and you can see here the count goes up if a patient arrives. And then here's some more variables that we have to initialize. We also had to sort some things, and sample the time of the first arrival, and then advance the simulation time to the first event. Okay, so a big part of the code has to do with this while loop. So this is basically just making sure that the simulation isn't finished. So if clock is less than your total simulation duration, then you can do all this. And this addresses the 3 states of the system and when they change. So here is if a patient arrives, and then here deals with if a patient leaves, and then here's just a normal admission. So there's nothing fancy going on here. So these just show how each state of the system changes and when.
So continuing the code with the different states of the system, this if statement is going through the state that says that if admission of patient following an early departure. So this is when a patient that is taking up a bed leaves early, and then the patient arriving is able to go in and take their bed. And then we have this conditional statement, this if, in this next statement, which is for referral or arriving patient. And so this is for when a patient arrives and all the beds are taken and none of those patients are leaving early. So then coming out of those if statements right here, you're going to store the current simulation time and then advance to the earlier time or the time of the next departure and of the next arrival. And then we have this next block of code, which is going to, since the clock now exceeds the required simulation time, it's going to reset, and then it's going to calculate the time since the previous event, and it's going to update. And then coming down here, you're going to start to compute your outputs. So that's your average utilization, your average referral rate, your average reduction in length of stay for referred patients, and then a list F for plotting the beds occupancy distribution, and we'll show some of those distributions in graphs coming up in the next couple of slides. So again, these are just some of your outputs. It's just displaying the values in a nice way. And so we'll continue on to the next slide. So for the simulation that we just went through, this is what the results should be. We did do this in MATLAB and we got it to run, but our values were significantly off, and we knew that because our utilization was significantly lower than what it was supposed to be coming from the example in the book. But this is what you're supposed to get when there are 10 bed wards with no early departures. And you can see that the utilization is around 70%. The proportion is around 12%, and then the early departure proportion is 0 because there are no early departures, and then the average reduction stay in days for early departures is 0 again because there are no early departures. And so as you can see, this is the bed occupancy distribution, and you can see that around 7 and 8 beds is what it's most common. So in the book, it also goes through a couple of different situations. So these are the results for a 20-bed ward with non-exponential service durations and no early departure. And as you can see, the majority of the beds are filled. They're around 15 or 14 is the highest distribution for that. And the utilization is still around 70%. Here's another example that the book did. So this is results for a 20-bed ward with non-exponential service durations, and it actually has departure up to 1 day early. And so as you can see, that increased the utilization by about 2% from the previous two, and then it's still having the most beds being taken would be 14. That's the highest probability of beds. So sorry for the lengthy video, but we just wanted to go through the code and the different results that you would get. But thanks for watching, and we hope that you learned something about hospital simulations through Monte Carlo.